Okay, so last time we started talking about the intercepts, okay? Tell me what you know about, what is this axis here? The y-axis. And what's the other name for the y-axis? Is the vertical axis. I love that. Vertical axis. What's the equation of the y-axis? X equals 0, okay? And then here, this is the x-axis. What's another name for the x-axis? Horizontal. What's the equation of the x-axis? Y equals 0. And you should memorize all of those things, okay? We keep talking about the need for memorization. So that could go on your page of notes. Okay, so using the intercepts to graph, we called, what is this form of a linear equation right here? This is called the standard form. Good. Standard form. And you notice it's different. It's not the same as y equals mx plus b. What's this form called? Yes, slope intercept. The mathematicians who created it were like, this equation has the slope and the intercept in it, the y-intercept, specifically the y-intercept, okay? Let's call it the slope y-intercept form or slope intercept form. Find the x-intercept. So when we graph, we really only technically need 2 points to graph a line, but we always want a third point so that we can check and make sure that we're accurate. So if we find the x-intercept, we're going to do that by allowing y to be 0, since y equals 0 happens to be the same thing as the x-axis. Once we do that and we solve for x, that will be our x-intercept. It will be an x value, comma, 0. It will be the ordered pair. And then you'll find the y-intercept. To do that, you're going to let x be 0, and you're going to solve for y, and then you're going to list the ordered pair. So it will look like this, 0y, which is the reason why here in the slope-intercept form, when x is 0, 0 times m gives you 0 plus b is b. So that's why this 0b is the y-intercept in that form. And then we're always going to want to check, because if I mess up on any of the x-intercept or the y-intercept, I can graph the wrong line. So we always want to have a checkpoint. The checkpoint is just a third ordered pair that is a solution to the equation. I'll show you how to get the checkpoint in just a moment. And then you're going to graph the equation by plotting all of the points and connecting into a straight line. Remember to put arrows on the end. Arrows on the end of the line. And that's because technically if you don't put arrows on the end of your line, then it doesn't continue for infinity, and it's actually not a line, but a line segment. Okay? So algebraically find the x and y-intercept for the equation x minus y equals 6. Then find one extra point on the graph and graph that equation. Make sure to label the x-axis and the y-axis and the intervals on the graph. The intervals on the graph is the same thing as I've been using a different word for intervals on the graph. It's the scale. So when you put numbers on your lines, and remember, you're always numbering the line. 1, 2, 3, 4, 5, 6, 7, 8. That just looks kind of neat and clean. I kind of like doing that skip counting. And remember, I'm always putting the number on the line. So I have 1, 2, 3, 4, 5, 6, 7, 8. -1, -2, -3, -4, -5, -6, -7, -8. So I'm still using a scale of 1, even though I'm only labeling every other one. Does that make sense? Okay, let's go ahead and find the intercepts. So the first thing we're going to do is find the x-intercept. To find the x-intercept, we'll go ahead and plug in y equals 0 into our equation. So our equation is x minus y equals 6. Oops, 6. There we go. I got carried away with my 0. So that x-intercept happens when y equals what? Y equals 0. So if we set y equal to 0, all that's left, x minus 0, is 6. What's x minus 0? So x equals 6. So that ordered pair will be 6, 0 is the intercept. So I can go over to my graph, and I'm going to go over 6, up and down 0. You notice that I'm on the x-axis. 6, 0 is my x-intercept. The x-intercept always happens on the x-axis. Good. Next one is I will find the y-intercept. So who can tell me what should I do to find the y-intercept? There's the instructions right there. To find the y-intercept, what will I do? Let x be 0. X equals 0 on the y-axis, right? So if I set x equal to 0, 0 minus y equals 6. How do I solve for y now? What's 0 minus y? Minus y. Minus y equals 6. Did I get y by itself? What do I need to do to get y by itself? Yeah, divide by -1. Y equals -6. So what's my ordered pair? 0, -6. And you notice that, do you think that anybody might make a mistake here ever with this, with the signs? Is that common? It really, really is. This is the reason for the checkpoint. A lot of people will make the mistake and they won't get a -6. If you graphed a +6 versus a -6, would that be the exact same line? No, it would be a completely different line. So what I usually do to find my checkpoint is I go ahead and graph my line. And I only need 2 points to form a line, so I want to try and graph it really accurately. Make your lines bold. Allow them to go through the whole entire graph, and make sure you put arrows on the end. Now what I can actually do is I can start to see the rise and the run, and I can find another point that is on the line. If I can find another point on the line and check that point, I can count it as my checkpoint. So the third thing is to find a checkpoint. This is 1, 2, 3. A lot of you were really liking, I saw that today in the tutoring center, people were using the steps, like step 1, do this, step 2, do this. That's good. Write out your steps. Why not? Okay, so can anyone see from the graph, can you see a point, any point that I could check? Tell me any point that's on the line. Elizabeth? 3, -3. So over here is 3, -3. Now there's an infinite number of points on the line. So I don't have to use 3, -3, but so long as it's a point on the line, I can use it. I can use any point on the line. So I'm going to check 3, -3. To check it, I'm literally just going to plug it into my equation and make sure it works. So this is an x, this is a y. I plug in 3 for x minus -3 for y, and I'm asking myself, is it equal to 6? If the point works, then that means it's really a point on the line. You see what I'm saying? So this would be 3 plus 3 is 6. And that works, right? 3 plus 3 is 6. I just want to show you what would happen if I graphed it incorrectly, okay? So let's say I were to have thought that this was +6. I'll just draw this line dotted. This is the wrong line, okay? But I just want to show you what a checkpoint would look like if it was wrong. So this is right here, the wrong line. And you notice that it goes through the point 3, 3. So if I did a check of 3, 3, I would have 3 minus 3 equals 6. I would get 0 equals 6, which is false. So this is the whole reason why we do a checkpoint, because if I got one of my intercepts wrong, then my whole entire line is wrong. And the way it will look if it's wrong is that one of the points, the only way you're going to know it's wrong is if you check, okay? And I will tell you right now that 100% of people who get the line wrong do not check. I don't know why it's so hard for me to get my students to check. Literally, I can get you to do math all day. The thing that you hate to do is check. But the only way you find your mistakes is if you check. Okay, so does everybody understand the idea of the checkpoint, why we do it, and why it helps? Okay, even here, if I graphed this incorrectly, you can see I can have a possibility of 4 different incorrect points. If I had gotten the X-intercept as 6 over here, this would be the wrong line, you know? If I got it here and here, this would be the wrong line. So I have 3 different incorrect lines and only 1 correct line. And I know it's correct because I checked it. So the checkpoint, it does count for points. Should say, you know, find the intercepts. Find 1 extra point. You see that? So that was in the instructions. Find 1 extra point. And you don't have to find it so much as make sure it works. Find it on the line. You know, a lot of times I'll see people plug in 1 and then they get fractions. Fractions don't help you really that much with graphing. I mean, it's okay. It's an estimate, right? Now here, this is really important. Rewrite the equation in slope y-intercept form or slope-intercept form. So what does that mean to get it into slope-intercept form? What do we have to do that? Yes, we want to solve for y. Solve for y equals mx plus b. That is the slope-intercept form. You need to memorize that form. There's a lot of memorization that goes into graphing, isn't there? So what are you going to do to get x by itself, or to get y by itself? What are you going to do to solve for y? It's the first step. You want to isolate y. So how can you get rid of x? Subtract x from both sides. Don't forget that negative. Negative y equals negative x plus 6. Does everybody see where I got that? Okay, and now what do we want to do? Is y by itself yet? And one of the biggest problems here is that people will leave out that negative sign. So to get y by itself, we need to, yes, divide both sides by negative 1. Everything, everything, everything. Negative divided by negative is a positive y. Negative divided by a negative is a positive x. Positive 6 divided by negative 1 is negative 6. So looking here, what is the slope and what is the y-intercept? That would be another way to check it, right? The slope is 1. M equals 1. Do you see where I'm getting m equals 1 from? And what's the y-intercept? Yes, or as an ordered pair, 0, negative 6. So a slope of 1, here's my y-intercept, 0, negative 6. It's the same thing, right? My slope of 1 means I rise how much and I run how much. 1, 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Any one of these points on the line could be a checkpoint. You could have even used a positive checkpoint, right? Positive, positive. 7 and 1. 7 minus 1 is 6. You see what I'm saying? You can use any checkpoint that's on the line. Okay, now it's your turn to try the next problem. So you get to do all of that. Test yourself. And then